Today we are going to be looking at a take-home data project. First things first, we need to understand the task. This particular assignment comes from Freedom Debt Relief, a company that attempts to aid people who have a substantial amount of debt, which they are no longer able to make the minimum monthly payments on, due to unexpected hardship. Now imagine that Freedom just ran a marketing campaign to promote their program and explain how it helps people achieve financial freedom. Our task is to assess the success of this campaign and make recommendations for future marketing campaigns based on the provided data. We are given 3 complete data sets that each span a duration of 5 months, and we know the cost of this campaign was $5 million. We know the campaign took place over the course of the 3rd month. Using that information, we are tasked with answering the following questions. First, how would you provide a quantitative assessment of whether the marketing campaign was successful? How and why did you choose your specific success metrics? Number 2, based on the provided data, how would you recommend the campaign strategy be adjusted in the future to improve performance? And number 3, how do you think the campaign performance would have changed if we did not run the campaign in month 3, but instead postponed it until month 6? Provide an incremental number versus your result in question number 1. In regards to the data, we're given 3 mock data sets. The first is client data, which contains some basic demographic data about a list of fictional clients. The second is deposit data. This contains data specific to client deposit behavior. And finally, we have calendar data, which is just a simple calendar reference table. Let's get started. We will be using Python and leaning heavily on the pandas library for this solution. Before we start any serious analysis, we need to get our data into a malleable form. Since our data is spread across 3 different files, our first step should be to read each file and merge them into one data frame for easier analysis and manipulation. All right. So all I've done here is just read in each of the provided CSV files and print out the shape and just the first couple columns of data, or a couple rows of data, from each data frame. Did that 3 times. And now that we have the data available to us, we can perform a merge in 2 steps. First, we will merge the client and deposit data frames on the client ID column. And then we will merge the resulting data frame with the calendar data set on the deposit and Gregorian date. One important thing to notice here is how we used different optional arguments in each of the merge steps. When merging the client and deposit data, the column that we want to merge on is named the same in both data frames. So we only need to specify the on argument. However, in the second step, the merge column has a different name in each data frame. In our freshly produced data frame, it's called deposit date, and in the calendar data frame, it's called Gregorian date. Because of this discrepancy, we need to tell pandas which columns to merge on using the left on and right on arguments. Left refers to the data frame that calls the merge, and right refers to the data frame being provided as an argument. And our data looks pretty good. But we do have one more problem for the eagle-eyed among you. The date column appears twice, once as deposit date and once as Gregorian date. This is because pandas treats columns with the same values but different names as unique columns when merging. But we can fix this quickly by dropping one of these columns. Let's get rid of Gregorian date. It's arbitrary. Both work. Okay, I just performed a quick drop, and now we are back to normalcy with only one date column. Much more reasonable. Now we can start actually getting ourselves comfortable with the data we have been provided. Let's start by getting a blanket understanding of some of our demographic data. We can use the value_counts method for our categorical data and the describe method for our numerical data. Okay, it looks like I did a lot here, but it's really nothing too fancy. Basically, just instead of combing through the data and trying to pick out what the scope of values we can get from each column and things like that, I just use Python to tell me. Value_counts gives us a list of a column's unique values alongside the count that each value appears. Describe, on the other hand, will show us box plot statistics like the min and max values, as well as the 25th, 50th, and 75th percentiles. So we can see that there are 4 different regions. We see West, South, Midwest, Northeast, nothing too specific. There are only 2 types of residence status, whether they own or rent their home. For client age, we can also dig a little deeper and create a histogram to get a more visual description of the age distribution, because these numbers, I can look at them and yes, they do mean the same thing, but it's hard to get a good understanding just from the numbers. So a really simple histogram, and we can see that most of the customers are between roughly 40 and 60 years old. There are no surprises in the months, and by grabbing the min and max of the deposit date data, we can see that our data spans from June 1st, 2019 to October 31st, 2019, right here. And then finally, we can look at deposit type and cadence, and we can see that there are 2 types of deposit type and 3 types of deposit cadence. This is just great to start painting a picture for us of what we're even dealing with here. Now that we have a very general picture of the data, we can start getting a bit more specific. I think I want to look at deposit amount first and create a basic plot that describes the sum of all deposits grouped by month. But before we start with that, we do need to fix a small problem with the deposit date column. If we go up, or even if we look here, we'll notice that the bane of many a programmer's existence, there are little tiny quotes around these numbers, which means it's a string. And that's going to mean we can't really do any, addition, subtraction, any kind of processing on the dates. So let's convert that into a proper date object. And luckily for us, Pandas conveniently provides the to_datetime method that allows us to do just that. I used the to_datetime method, and now I just reran that same min and max thing, and we can see that we have now an object, a timestamp object, which will be much nicer for us to work with. So for starting to get this plot going, we're going to use the ever useful matplotlib library to build our plot. Let's import that quickly and do some housekeeping like setting the figure and font size so we can get that out of the way. Great. Now it's as simple as using the groupby method to sum all the deposits for each given month and then feeding that data into pyplot in order to plot a line. Alrighty, so as you can see, I just used a groupby on month name, and then we're summing deposit amount, and then we just feed that into the plot function. This is a super simple line graph, so we don't need to do anything fancy besides setting a basic title, labeling our axes because we're not naughty, and here we go. Here is our kind of first picture at what the data is doing over the course of our campaign. Out of curiosity, let's see if the plot changes if we replace the sum of the deposits with the number of deposits each month. The only difference here is we use the size function instead of the sum function when doing our aggregation using groupby. So as I said, pretty much the same code pasted again, but this time we're using, instead of up here where we were summing the deposits, so the actual deposit amounts, in this case, we are just getting the size, so we are counting the number of deposits. And it looks pretty much the same. Great. While we're at it, let's repeat the same procedure, grouping by deposit type and cadence. All right, let's take a look at that. So far, we're not trying to make any conclusions right now. We're just building up a picture in our head for what's the story this data is telling, and we're not trying to make any conclusions because we don't have the full picture yet, but we're just trying to get that picture. So here we have the deposit amount by type, so we can see actual deposits versus scheduled deposits, pretty close. And then we have by cadence, so monthly seeming to be the most popular, then bi-weekly, and then extra. We can take this a little bit further by grouping on multiple columns to show some deeper insights. As an example, let's plot the sum of deposits for each month, split up first by cadence, then region, and finally residential status. Okay, so I've gone ahead and done that. Here we have deposit amount per month and cadence. So we can see each different line is a different cadence, and then the amount that's being deposited summed for the month across those cadences. Likewise for the regions, we can see the West is quite dominant. And finally for residential status here. Versus owning versus renting. As I said before, I've purposefully kind of been avoiding making any hard conclusions yet. We're just getting a top-down understanding of the data so we can start to consider the questions so we have a strong base. I think we're at a point where we can start actually getting into the questions. So let's remind ourselves about which those were. So as a quick reminder, question 1 was to provide a quantitative assessment of whether the marketing campaign was successful. How and why did you choose your specific success metrics? We can already answer this fairly confidently using the plots we have already generated. We were told that the ad campaign was running during the 3rd month of our data, and a huge spike can be noticed in this line plot showing the deposit amount per month. The one I'm talking about is this one, the very first one we made. Since then, the deposit amount has been slowly decreasing, but has remained much higher than pre-campaign levels. We can see, we were starting out way down below, and now we're up here. That's all well and good, but we were asked for qualitative assessment, so let's put this into numbers. During the month that the campaign was running, Freedom Debt Relief received an almost $10 million increase in deposit amounts than the previous months. In the months following the campaign, the total deposit amount starts to slowly decrease, but remains at a level much higher than pre-campaign. $8.5 million in month 4 and $8 million in month 5. We know from the task description that the cost of the campaign was $5 million. Summing the above numbers, we get that the deposits increased by a total of $26.5 million during and after the campaign. Now, deposits don't equal net profits for Freedom. I did a quick Google search and I found that the company charges fees at rates between 18% and 25%. This rate is likely based on a myriad of factors and handled on a client-by-client basis. However, we're given no information about this in the data or the task description. In lieu of this, let's take a page out of Big O's book and assume the worst case scenario of 18% fees for all clients. Using this rate, we can calculate a profit of about $4.77 million for the campaign. While initially it may look like the campaign resulted in a net loss of about $23,000, it's important to remember that this is our absolute worst case scenario. Additionally, we don't know how far into the future clients that were acquired as a result of the campaign will continue to use Freedom's services and incur fees. Speaking of new clients, we can use Python's set methods to assess the number of new clients that were brought on during and after the campaign. We can build sets of unique clients that made deposits in the time period before the campaign, during the campaign, and then after the campaign. By using the difference method, we can find how many new clients were acquired during the campaign. It looks like about 11.5 thousand new clients joined during the campaign and a further 750 joined afterwards. It's important to note that these numbers are not reliable. It's possible some of these clients made deposits prior to month 1 of our data, meaning they are not actually new clients. Nonetheless, this can still be an interesting metric within the limited scope of this assignment. One final insight we could look into is to investigate how the number of scheduled and actual deposits changes through time. We can follow the same steps we did in our initial exploration of the data to create a quick plot for this. So once again, just using that handy groupby method and matplotlib to create a simple line graph, and there aren't really any surprises here. As expected, the plot very closely matches the distributions of our previous plots of similar data. We see a large spike of about 25% or $10,000 during the month of the campaign. And despite gradually decreasing over the next 2 months, this remains well above totals of $50,000 for each type. Question 2. Based on the provided data, how would you recommend the campaign strategy be adjusted in the future to improve performance? This one is a bit trickier. Almost all the plots tell pretty much the same story with the same trends through time, making it difficult to make any suggestions. One thing we can examine, however, is more targeted marketing. Back when we were initially exploring the data, we noticed that the majority of the people in the data are middle-aged, and most of them are homeowners. Let's make a quick plot to show the deposit amount changing through time, split up by age group. Here, I have created a function that converts an age into a discrete age group by simply dividing it by 10. After that, I can add a new column to the data frame that contains this age group information using the apply method. Note that we cast the result of our division to an integer, which will effectively give us the floor of the result. And we can see that here, I've just used the apply method here, and then if we scroll down and scroll over, we can see we now have this age group. So 91 gets cast to 9, 24 to 2, etc. It basically just between 1 and 10. Just simplifying the we're creating bins for our age group. All right, let's see if we can learn anything graphing the deposit totals grouped by this new column. So pretty sure you know the drill at this point. I'm just using groupby and an easy plot. And we can see a large increase in middle-aged customers with little to no increase in very young and very old customers. This might seem like epiphany at first, but this isn't particularly noteworthy as we have so few data points for the extremes of the age spectrum. We are far less likely to see noticeable change in these groups. For the rest of this analysis, let's specifically focus on middle-aged customers. We can start by grabbing this slice of our data that is just clients between the ages of, let's say, 40 and 60. So here I just made a new data frame and I'm just grabbing clients between the ages of 60 and 40. My new data frame has a shape of this. And then I just made a quick graph using only this data frame showing our kind of usual sums of the deposit amount. This time I've split it by the deposit type, whether it was actual or scheduled. But let's specifically take a look at extra deposits. These are non-recurring deposits that could represent existing clients depositing more than their usual scheduled monthly or biweekly deposits. So the first thing we do here is we're gonna just sum the total amount of extra deposits in our subset, so middle-aged customers. Then, if we do the same for the whole overarching data set, we can see that our subgroup is responsible for 42% of total extra deposits. However, they're only, if we're comparing just the raw number of clients in each data set, we can see they only represent 37% of clients, which is something of note. Let's explore these extra deposits a little further to identify more client groups that might interest us. So, using the value_counts method we used in our initial exploration on some potential columns of interest, I note that most of the extra deposits are made from the West region. However, this isn't particularly noteworthy because this is expected and matches the other deposit types, so no particular trend there. Clients who own their residence are roughly 2.33 times as likely to make extra deposits than clients who rent their residence, and the majority of deposits are observed in month 3 when the campaign was running. Post-campaign numbers for extra deposits are still elevated though. They are 33% higher than pre-campaign. Some potential recommendations we might make based on our findings for this question are target the campaign specifically at middle-aged clients, target the campaign specifically at homeowners, or run the campaign over a longer period of time, particularly to encourage clients to make more extra deposits. All right, last question. Question 3. How do you think campaign performance would have changed if we did not run the campaign in month 3, but instead postponed it until month 6? Provide an incremental number versus your result in question 1. This one requires us to make a few assumptions and to do some processing in order to simulate the postponement described in the question. We can start by assuming that any clients who made their first deposit in the 3rd month of the dataset are acquired due to the campaign. As we discussed before, this isn't necessarily true. However, we are in a limited environment here and we have to start somewhere. We can then postpone all deposits made by these new clients until the 6th month as described. In order to do this with code, we will follow the following 3 steps. First, identify which clients made their first deposit in the 3rd month, the clients that were acquired due to the campaign. The good news is we've done this in a previous step. Number 2, postpone their deposits until after the 5th month by adding exactly 3 months to the date of their deposit. And number 3, rerun our analyses from question 1 and summarize the differences. My first step, I quickly made a copy of the data and used our previously created sets to create a set of our new clients. That is, clients we have a reason to believe were acquired as a result of the campaign. So you can see here, I'm just using the same difference method that we used previously and these 2 sets to build our data frame actually of new clients. Next, I made a quick and dirty function that accepts a row from our data and adds 3 months to the deposit date. It does this by first transforming the deposit date into a date time type and then adding 90 days to it. Then, since the month names are strings, we don't really have any choice besides doing it manually. So I just used a chain of elifs to add 3 to each month name so that we could have month 6, 7, and 8 recorded. Then, likewise, we've done this before as well. I used the apply method to basically run this function on the whole data set. And with our newly simulated data in hand, we can start making the same plots we used in question 1. One thing to note is we only postpone if, I forgot to mention this, but if the client is in our set of new clients. So we do check if they're a new client to postpone them. Otherwise, we keep them as they are. All right, and then once again, we start with this kind of first graph that we have been basing a lot of it on, just by the total deposit amount grouped by month name, and our result looks a bit weird. This is because we have no baseline data for months 6, 7, and 8, so we only have the data coming from our new customers. Let's remedy this by finding the average deposit amount from the previous months and adding it as a baseline to our new 3 months, our 3 new months. So all I did here was calculate our monthly deposit average using the mean function, and then I redid our grouping, and then for month 6, 7, and 8, I manually just added on that monthly average so that we have less of a huge drop off for 6, 7, and 8. And then I plotted it again, and we have something that looks a little better, at the very least somewhat more logical. So let's examine the key differences between this scenario and our findings from question 1. So, during the month of the campaign, Freedom received almost $2.5 million increase in deposit amounts than the previous months. This is a pretty small increase when compared to the $10 million we found in question 1. In the month following the campaign, the total deposit amount continues to increase to its maximum at $33 million, before dropping to $31 million in the last month. In this new scenario, we can calculate that the campaign resulted in a rough increase of $8 million in deposits. In question 1, this number was much higher at $26 million. Bringing back the cost of the campaign at $5 million, we calculated that the original campaign was borderline profitable. Given our simulation of the scenario, it's pretty clear that postponing the campaign would not have been the right choice. And that's it, that's all 3 questions answered. You'll notice that I didn't give, super concrete exact answers, just kind of suggestions for the direction that you could take given the information we've gathered. Because the goal here isn't to provide, a cookie cutter exact way to solve this exact problem, but instead give just a general framework for tackling assignments like this. Please do let us know if you have any questions.